morning, everyone. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirrabbilalamin. Wabihi nasta'in ala umuri dunya waddin. Sayyidina Muhammadin wa ala alihi wa sahbihi ajma'in. Let's pray and praise to Allah subhanahu wa ta'ala for blessings and mercy. Therefore, we could attend this valuable forum, inshallah. And secondly, salawat and salam may always be upon to our Prophet Muhammad sallallahu alaihi wasallam, who brought us from Jahiliyah era to the lightning era. May all of us have Allah subhanahu wa ta'ala and also our Rasulullah for their shafaat in hereafter. The respectful head of Department of Industrial Engineering, Mr. Muhammad Ridwan Andi Purmono, the respectful Secretary of Department of Industrial Engineering, Mr. Muhammad Ragil Suryoputro, the respectful head of Master Program Industrial Engineering, Mr. Winda Nur Cahyo, the respectful head of Undergraduate Program in Industrial Engineering, Mr. Dr. Taufik Imawan, the respectful Secretary of Undergraduate Program in Industrial Engineering, Mrs. Sri Indrawati, the respectful Secretary of Undergraduate International Program in Industrial Engineering, Mrs. Ira Prosmawanti Rahmadewi, the respectful all of the speakers and all of the lecturer in Industrial Engineering Faculty of Industrial Technology, Islamic University Indonesia, and also all of the participants who are joining the Stadium General. There are several of it. Let me mention it one by one, if I can. Universitas Muslim Indonesia Makassar, Universitas Cokro Aminoto Palopo, Teknik Informatika UIN Suskaryau, Universitas Dian Nuswantoro, Universitas Muhammadiyah Ponorogo, PT Pura Barutama Yogyakarta, PT Pura Barutama Jakarta, and also there are many all of the universities that I can mention it one by one. So before the time, it's still 10 minutes to the 9 a.m. in the morning. Let me ask the committee to play some videos, please.
The world is changing. Industries are moving faster, growing bigger, and branching out to become the number one for their customers worldwide. As an advanced educational institution in Indonesia, we are the solution to face this challenge. Established since 1982, the Department of Industrial Engineering, Universitas Islam Indonesia, consists of 3 study programs: undergraduate program, undergraduate international program, and graduate program. With a vision to become a quality, superior, and innovative department in developing the science of industrial engineering at an international level based on Islamic values. We develop an effective learning environment, a green learning environment, supported with fast internet connections, unlimited cloud storage, and the flexibility to study anywhere. With these facilities, communications and discussions between lecturers and students are easier and more flexible. The learning atmosphere in the classroom is made to be conducive and interactive. By developing a responsive curriculum in industrial engineering, Universitas Islam Indonesia, this department has been accredited A since 2003. The curriculum is developed based on what is needed in today's industrial challenges, which are based on the 3 main pillars of industrial engineering, namely production engineering, operational science, and human factor engineering. Because of the dynamics and fast technological developments in the industry, this is how this campus supports its students to compete in the workplace. With 6 laboratory facilities in UI's industrial engineering, this makes us an industrial engineering department with the most complete lab facilities, including integrated manufacturing systems, work system design and ergonomics, enterprise resource planning, industrial modeling and simulation, and industrial statistics and optimization. With this, the space to develop in academics through these lab facilities allows students to think creatively and innovate in the fields they like. All the lecturers, staff, students, facilities, and environments encourage students to continue to develop and innovate methods in industrial engineering to find newer methods that can solve problems that occur in society. Achievement is not only obtained in the classroom by getting good grades, but also by participating in national and international competitions. By joining several activities outside of campus, students can improve their knowledge and also broaden their networking so that companies will be interested in recruiting students. Before students graduate and seek jobs, it is compulsory to follow an internship program in a company. This internship program is an opportunity for students to experience the atmosphere of working in a company. Several great companies are already collaborating with us on this program. In addition to develop academically, students also can sharpen their soft skills through student activities such as Saman, basketball, futsal, and campus organizations. And for those who are in difficulty for fulfilling the college fees, there are many opportunities to get a scholarship. All of these facilities are available to make your college life guaranteed, including pharmacies, hospitals and a gym for your health and student counseling, and information center for your soul. Because this is the best place to learn at Industrial Engineering, Universitas Islam Indonesia.
Life is a journey in which dreams become the destination. And education is an essential part of it. Education is where character is defined. It is where intellectual brilliance is formed. And it provides a vast space to find and share experiences, open a mind, and broaden knowledge. To explore the utmost potential, it requires diligence, perseverance, and discipline, supported with a firm faith and exceptional character. Because intelligence plus character is the goal of true education. As the oldest nationally founded university in Indonesia, we are proud to be the first one to offer an international program for business and economics, law, and industrial engineering. International program Universitas Islam Indonesia prepares and provides chances to achieve the global experience by offering various programs abroad in collaboration with universities across the world, exchanging traditions and culture. We live in an ever-changing and limitless world, a world where opportunities and challenges are on every corner. These new changes must be addressed attentively, faithfully, and wisely. Education prepares you to continue your journey to new places and challenges because you will become a part of competition locally and globally. And to be the great leader, you need education, because education is the most powerful weapon which you can use to change the world. Now, it is time for you to enjoy the journey.
Okay, so that's our video profile of Industrial Engineering International Program faculty. Because it's already 9 a.m., let me open this general studium. So before, ladies and gentlemen, and our participants, to initiate this morning agenda, let us recite Basmalah together. Bismillahirrahmanirrahim. Before we jump into the next agenda, let me introduce myself. My name is Safina Abdulaziz Baraba, as your Master of Ceremony in this first study general, called the Big Data Accelerated Data Science Ecosystem with the GPU and RAPIDS. And the second topic, it's about the research opportunities on big data application in industrial engineering. There are three kind of studium general that we had, and this is the first time. And for the detailed information about the second and the third studium general will be informed later on in the last session of this studium general. Let me read it today's agenda. The first one is opening that we already held. The second one is opening speech by the head of undergraduate program in industrial engineering department. And the third one is introduction to the speakers. And the fourth one is the question and answer related to the topic. And the fourth one is the closing. So we're jumping to the second. It's the opening speech by the respectful head of undergraduate program in industrial engineering, Mr. Dr. Taufik Imawan. Time is yours.
Okay, thank you for the time. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Excellencies, colleagues, ladies and gentlemen. It is a great pleasure for me to declare the lecture series on Big Data and Artificial Intelligence hosted by National Program Department of Industrial Engineering, Universitas Islam Indonesia. I'm delighted to welcome so many of you to this webinar as first lecture of the lecture series. Today, webinar will discuss accelerated data science ecosystem with GPU and RAPIDS and research opportunities on big data for industrial engineering. The tremendous development of information and communication technology has made many changes in all aspects of our life, including the business and industrial environment. It leads to the transition from hand production method into machine-driven, from smart automation to smart manufacturing. The evolution of social web, interconnected devices, automation, cyber-physical system, IoT, industrial IoT, a massive amount of data has been generated and its optimal utilization has contributed to the emergence of Industrial Revolution 4.0. Even now, we already shift to Industrial Revolution 5.0 in the artificial intelligence era. International Program, Department of Industrial Engineering, Universitas Islam Indonesia, respond to this our learning system. One of them is by sharing knowledge about how big data becoming so crucial today. Learn the implementation of big data and uncover research opportunities on big data for industrial engineering. We expect that this webinar series will motivate us to industry of our nation to recover from the recession. We also inviting you to join again series that will be conducted. The second webinar will be conducted on Wednesday, November 11, 2020 about implementation artificial intelligence in the healthcare industry, genus for COVID-19 detection, telehealth, and cybersecurity, in collaboration with Badan Standarisasi Nasional Indonesia, Universitas Indonesia, Gajah Mada University, then Underwater Laboratory USA, IEEE Indonesia section, and Ministry of Health of the Republic Indonesia. Then the third webinar will be conducted on November 14, 2020 on project management. And the fourth webinar will be conducted on November 21st, 2020 on machine learning. We hope all of you can participate with this lecture series. By saying Bismillahirrahmanirrahim, I hereby declare that the lecture series is officially open. I wish you all of you very grateful lecture today. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much for Mr. Dr. Taufik Imawan for already opening this general by the speech. For the next agenda, without further ado, let's moving on to the next agenda is the introduction to the speakers. But first, let me tell you about our moderator at first. He's a secretary of Department of Industrial Engineering, and he's also a lecturer in undergraduate international industrial engineering. And in this academic year, 2020 and 2021, he teaches academic writing and communication, physiology, work and measurement, and also productivity engineering. Please welcome our amazing moderator, Mr. Muhammad Ragil Suryaputro. Time is yours.
Thank you, Mbak Safina. Can you hear my voice clearly?
Yeah, sure.
Okay, thank you. Okay, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Waalaikumsalam warahmatullahi wabarakatuh.
Respectful head of Department of Industrial Engineering, Faculty of Industrial Technology, Universitas Islam Indonesia. The respectful head of undergraduate program in industrial engineering, international program and magister program, Faculty of Industrial Technology, Universitas Islam Indonesia, and also the respectful lecturers of Department of Industrial Engineering and all the students and guests in industrial engineering, and also as well as the respectful guests. Good morning to you all. To all students, welcome aboard to Faculty of Industrial Technology in Department of Industrial Engineering. Alhamdulillahirabbil alamin. Let us pray and praise to Ilahi Rabbi for the blessing and mercy. Therefore, we could attend this valuable forum. Inshallah, amin amin ya rabbal alamin. Ladies and gentlemen, and our dear freshmen, to initiate this morning agenda, I would like to welcome you to the webinar of the Big Data, Accelerated Data Science Ecosystem with GPU and RAPIDS research opportunities on big data application in industrial engineering. First, let me introduce myself. My name is Muhammad Ragil Suryaputro. I'm from Industrial Engineering Department, Universitas Islam Indonesia. I will be responsible for hosting this presentation today, and I'm glad to welcome both Mr. M. Andi Arifin from Nova Global PT Ltd, who will present Studium General Accelerated Data Science Ecosystem with GPU and RAPIDS, and also Mr. Muhammad Ridwan Andi Purnomo, STMSc PhD, as the Head of Department in Industrial Engineering, Faculty of Industrial Technology, Universitas Islam Indonesia, who will present Studium General Research Opportunities on Big Data Application Industrial Engineering. The biography of Mr. Andi Arifin is Mr. Andi Arifin SSI Com was born in Bogor, Indonesia, around these dates, yeah, in November. So he will be having birthday celebrations on the next week. The contact details that Mr. Andi Arifin is from Greenland in Batam, but he now works at Nova Global Singapore, PT Ltd, as a system engineer, high performance computing. He has responsibility on design, commission, and supports customers' HPC cluster, and also explore and propose solution and service products based on market trends, and provide technical guide, training, and consultation service to our customers engaged in HPC GPU software programming, cloud, and AI. So he has notable projects involved in Singapore and Malaysia, merely in NTU, NUS, and also another university and organization. His educations, the highest level of education is from Telkom University in Indonesia, Bachelor of Computational Science. He graduated on 2016. He has a lot of technical skills like operating system, SPC, cluster management, SPC, batch scheduler, storage system, and also programming, scripting, and etc. He has numeral certification, basically from NVIDIA Partner Network. He has successfully completed the Tesla Technical Curriculum, DGX Technical Curriculum, Data Science Foundational Curriculum, Compute Technical Curriculum, Compute DGX Technical Curriculum, Virtualization Technical Curriculum, and so on. But without further ado, I would like to call Mr. M. Andi Arifin to present his case. Good morning, Mr. Andi Arifin.
Good morning, Bapak Ragil. Thank you for the warm welcome on today's event. Such a pleasure among all of you today, and thank you for the birthday wishes that you mentioned earlier just now. Yeah.
Yeah, please, Pak M. Andi Arifin.
Let me bring up my slides first. Hold on.
Yes, please.
Okay. All right. Can see the screen?
Yes.
All right. Thank you.
And it will be around 45 minutes.
Sure.
Enough, sir?
Yep. Okay. Thank you,
Okay.
Bapak Ragil. Okay, so good morning, everyone. My name is Andy, and I'm an HPC system engineer at Nova Global. So today, I've been taught by Ibu Emma earlier to present this kind of topic, which is accelerated data science ecosystem with GPU and RAPIDS. But before I start presenting our topic for today, let me present or introduce our company first. So our company is currently situated in Singapore, which is established almost more than 2 decades ago. And then currently we are operating mostly in Asian countries like Singapore, Malaysia, and Indonesia. And our current focus is right now in HPC and AI type of deployments and services, where most of the times we are supporting our customers in the high performance computing clusters, deploying their AI system, their AI infrastructures, and so on. And then for us, we have been also partnering with some of the technology leaders like Microsoft, NVIDIA, Dell, and then some of our other partners also. And then this is what we have been doing over the past 10 to 20 years. So we have been, other than supporting this kind of infrastructures like the HPC clusters, cloud, grid systems, we have been also supporting our users with scientific applications that they are trying to run on their systems. And then we have been also supporting them with this kind of training, consultation, code development for GPUs, deep learning, machine learning, and AI. And then we have been also conducting regular training or workshops, like for example, like this one, which is RAPIDS for accelerated machine learning with GPUs. And then other than that, we also provide support and services for our customers. All right. So I think there would be a lot of things that I would like to talk for today event, but due to the time constraint, I think we try to make our talks today brief and short, clear and concise. So the first few things that I would like to talk for today is actually how the data science currently become a trend, and then how is the data science landscape and how is the data science ecosystem right now happening around the world. And then with those kind of challenges that is keep growing, how we could tackle this kind of problem, especially in terms of the performance, how we can accelerate these kind of challenges with newer infrastructures, with newer devices, with newer algorithms, with those things that is functionally better to provide more productivities or provide more performance. And then we will also talk about some use cases where RAPIDS especially can be beneficial or can help industry partners, can help the customers accelerate their challenges, their problems. And then we'll be also talking about an in-depth observation into RAPIDS, like how is the architecture underneath of the RAPIDS itself, how is the API that is provided by the software, and then at the end we'll be review on how you can get started on trying RAPIDS, and then at the end we will see some live demo into it. Okay, so without further ado, I think we can start with our first topic, which is the data science ecosystem and trends. I think for these slides, everyone is already know that today the realities of the data, the growth of the data are becoming more and more massive. We are not talking about gigabytes, petabytes, but we are now already in an era where each of the day there is ton of data, there is more than petabytes of data that is generated on each day. Like for example, when we are talking about data that is captured from an enterprise data, social media like Facebook, Twitters, and so on. And then there is also data that is coming in from a sensors, IoT, 5G, and so on. These are the device, these are the media that is providing us with a lot of feedbacks, a lot of informations, which is very massive. And then if we couldn't find a way to make this kind of information useful, then this data is becoming actually a junk, because there is no useful information that we can capture from this kind of data if we didn't process it, or if we couldn't find any pattern from the data. So another interesting data that I found on the internet also is that this kind of specialists, this kind of jobs is becoming a trend, becoming an emerging jobs in Indonesia. Like for example, if you take a look at the latest data from LinkedIn, which is a popular social media for a professional, for a job seeker, for example, then we can see that AI specialists and the data scientists are among top 10 of the jobs that is becoming a trend over the past 2 to 3 years. So when we take a look at these kind of jobs, we can see that between these two, there are some similarities. Like for example, data analysis, deep learning or machine learning are becoming a skill that everyone, I think, must have, like, if they are intending or if they want to work in this kind of industries, like for example, IT services, computer software, banking, internet, financial services, and so on. So these are becoming more and more useful, and then this is becoming getting hotter and hotter from the industry partners. So I think we will take a look on why these are becoming a trend. So as a data scientist, I think we would already know that these are just some challenges that most of the data scientists, most of the researchers are complaining, are answering, getting questions into it. Like for example, when they take a look at the data that they have in their industry, like for example, we have some customers working on analyzing data that is coming on a transportation company, ride-hailing company in Singapore. They have a data scientist team there, and then we heard from them that there is about 10 terabytes of data that is generated from the application itself, containing all the data related like trips, tariffs, and then the customers' waypoints, like for example, from which point to which point they are going, which transportation mode that they are taking, like for example, whether they are taking uh, taxi or whether they are using the services for some sort of services like food services, delivery services, and so on. So in just in just one region, which is Asian, uh, they generated around 10 terabytes of data each day. So they need to find a way on how to deal with this massive amount of data. Because if you just use a traditional method of analyzing the data, like for example, those kind of traditional style of doing it, like for example, using, uh, uh, I think the most uh, classic way of analyzing the data, I think everyone is already using it, like Microsoft Excel, but that is not a tool, that is not a software that can be very helpful. I didn't say that Microsoft Excel is not a good product. It's actually a good product, but for this kind of problem, it's not a tool, it's not a right way, it's not a right tool to deal with these kind of challenges. So we need to find a better way. Like for example, if you are working on this kind of challenges, like for example, I think you have been previously heard about those kind of libraries that is offered through Python, R, and so on. There is a lot of libraries that can help uh, to solve that kind of challenges, but uh, it's still not enough tools to deal with this kind of challenges. So we need something more. We need something that can offer much bigger performance throughput into this. So we see how later on Rapids can help you on this part of challenges. And then other than that, I think we already know that some of the other challenges like more complex workloads and then the more tedious data preparations, like for example, we know that among those data that is generated, I think only 5 to 10% from this data is the one that is actually getting precious informations. The rest are actually junk, and then most of the time we can just delete it or ignore it. And then in terms of providing the results or providing the insights from the data, training the data can be becoming more and more longer due to these kind of challenges. So that are some of the challenges why we need something better, something more advanced to tackle these kind of challenges. Okay, so uh, how we can tackle those kind of challenges? I think we already know that uh, in a computer era, every year, every decade, there is more and more software that is coming in. There is more hardware, newer architectures uh, that is introduced by the companies, by the IT companies. Like for example, uh, this Rapids is actually a new software SDK that is recently announced by NVIDIA in about, I think, 2 to 3 years ago, which is aimly which is aiming the data scientists to accelerate their workloads. So how we can accelerate the data scientist ecosystem, the data scientist problem with Rapids, we will see how to do that in a short time. So at a glance, Rapids is actually a suite of open source tool, an end-to-end data science tool. And then this one is built on top of CUDA, which is programming language, the programming APIs that is offered through the NVIDIA GPUs. And then in terms of the API that is offered by this toolkit, it is very close to what you have been, I think some of you or most of you are already familiar with. Like if you are doing data science data science, data analytics with Python. I think most of you would be already quite familiar with pandas or scikit, which is a very popular libraries to do data cleaning, data transformations, even to do machine learning algorithms or machine learning analysis with Python. So that is what Rapids is all about. And then why Rapids are nowadays getting more and more what they call it, why Rapids are nowadays getting more and more uh, ideas from the partners and then from other people around the world. Why they are now started to look into it is because if you take a look at the day in the life of data scientists, most of the time they are actually dealing with a problem that is not supposed to be a thing that they are working on, like for example troubleshooting the codes, debugging with the issues that they have in the codes, and then the long or the more complex, very complex workloads, very complex data that they are dealing on, and then they are actually not getting focused on what they should do, which is analyzing the data because of those kind of bottlenecks, like for example, preparing the environments, preparing the hardware, preparing the software, and so on. So this is not the thing that they should focus on. They should focus on how they can analyze the data in a fast way, and then they can present it to their management, to their company, and then the company can benefit from these insights that the data scientists produce. So I think this is how a typical data science workflow, a machine learning workflow would look like. So I think every kind of machine learning challenges, data science challenges would start with how you get your data, which is coming from the data sources. Like just now, we already mentioned that the data can be gathered from any sources like IoT, social media, and so on. And then they put all of this data into a data lake, a data warehouse where they keep all of the data into a single source, which is usually a local source, like maybe if you are working on a local system, then you put it in your computer or in your PC and so on. And then after that, once you have your data ready, then you can start preparing the data, like for example, do some cleaning or choose only the data that you think is very useful to you, or can be very useful to the organizations that you are working on, for example. And then once you have your data prepared, then you can start training your data or do some sort of applying maybe some technique, applying some algorithms that is at the end, it should provide you with insights or predictions on what are the informations that you can get from this data. So the one that is highlighted on the center is actually the one that is time consuming, which is an inefficient workflow at a time. And then these are the challenges that is actually wasting the data science productivity. So this is where Rapids is trying to focus on in terms of accelerating the data science ecosystem, which is help you to prepare the data and help you to train the data. So Rapids is not a tool that can help you to accelerate how you get the data from the source to your data lake. It's not something that can help you to accelerate your data download, for example. Not is Rapids is not for that one. Rapid is mostly useful for this kind of items, which is the data preparations and the training. So in terms of the data scientist perspective, Rapid should provide them with reduced training time because of the performance that is offered. I think later on we will see why Rapids can be very powerful in terms of the training and the data preparations just now. And then in terms of the integrations with your current workloads, with your current projects, for example, using Rapids into an existing projects that you are currently working on, especially if you are working on Python, is very easy. Is you just need a very minimum code change if you are going to use Rapids as part of your code or as part of your program. And then Rapids is also open source. You can see all of the source on GitHub. So this is why Rapids can be uh, very nice or very easy to talk with because of these features that they offered. So when we are talking about Rapids, there are some there are some libraries or there are some main functions that is offered in this toolkit. First of all, they have libraries that primary functioning as a data preparation library, which is called CUDF. So basically, CUDF is a GPU accelerated compute library for in-memory data preparations. So when they are working with the data, usually they put the data in the device memory, like a GPU memory or system memory. But in Rapids, I think we already know that on some cases where the data are very big or the models are very complex, GPUs can be very powerful when compared to the CPU in terms of the performance. So later on, we will see how these CUDF libraries can do that kind of objection in terms of doing the data preparations. And then when we talk about implementing CUDF in your codes, in your projects, implementing this is a very simple, is a very easy to use, because if you have been familiar with those data science tools like what they call it, like NumPy, Pandas, or Scikit, then using CUDF shouldn't be a problem with you, because when the creator of Rapids, when the engineer of Rapids creates this CUDF, they try to make the API, they try to make the function naming as close as possible to what Pandas offered. So replacing Pandas with CUDF shouldn't be much problem. And then the next main libraries that is offered through Rapids is called CUML, which is one of the libraries in Rapids to help you with model training, GPU accelerated machine learning algorithms like to do classification, regressions, and so on. And then the last but not least is for visualizations or graph analytics, which is another set of libraries that can help you with visualizing your data, or for example, creating some sort of graph analytics in your data that you are working on. So there are three main libraries in Rapids that can help you towards exploiting your data science ecosystem. And then this is actually just an example on how easy to migrate your existing code from a CPU-based algorithm with those traditional Python libraries like Pandas or Scikit. And then if you migrate the codes to a Rapids compatible code, you actually just need to change the way you import the libraries, which is in Python, you usually change the very first few lines of the codes where you import your libraries. So later on, I'll also have example that I already prepared, and then later on you can also try on your PC or, for example, on a cloud system if you have access into it, and then you can try and see by yourself how easy to use Rapids as part of your existing data science projects, for example. So there is actually some pillars or some underlying ideas why Rapids can be very powerful. Of course, the first thing is actually because they are built on top of CUDA architectures, which is running on top of the NVIDIA GPUs. And then when we talk about these architectures, we are talking about ten thousands of cores that is included in the GPU. And then this can provide you with a very massive parallel processing. So in terms of the performance, of course, this is much more faster. This is much more powerful when compared to CPU-based processing. And then when we talk about dealing with such massive data, usually in a typical industry deployment or in a typical organization deployment, they are not only using just a single machine, but usually they are working on clusters on multi nodes or a multi system deployments, and then they can distribute the workloads among multiple systems or multiple computers, and then this can provide you with much faster results because of more and more parallel processing that can be done at a time. And then other than that, of course, Rapids is integrated software, and then all of the things that you need to do data science analysis is already included in Rapids as a bundled package. So by using Rapids, you should be able to have access into all of these features like the one that I just mentioned earlier. So I think I just do a quick intro into this. So basically, these are just some examples where Rapids can be very powerful if you compare these kind of clusters compared to this just a single GPU system, which is called, we call it as a DGX systems by NVIDIA. So the performance that is offered between this single system and clusters that is, actually this one consists of 300 servers, is can be met, the performance of this CPU servers can be met with just a single GPU servers. And then when we take a look at some parameters here, of course, operating just a single system is much more cost effective and then space effective, and in terms of the power is also much more power effective to operate just a single system like this without losing any performance that is offered by the traditional CPU based system like that. So these are just some benchmark. So in a glance, by using Rapids, the performance that you can expect is most of the time is between 10 to 50 times faster. And then, so that is why Rapids can be very unique way of dealing with such challenges offered in data science challenges. Okay, so after this, we will see some use cases where Rapids can be very useful. So I think on almost any sectors that you are working on, or almost any sectors that is exist in the world, like consumer internet, financial service, healthcare, retail, I think all of these industries generate a lot of data, and then in any industries, I think they have their own challenges, they have their objective that they are trying to to solve it. And then rapids can be very useful for any cases in any industries, as long as they have the data, as long as they have the information that they would like to process, right? So, like for example, if we take a look at some of these examples, I think I can just skip this. So this is one examples where rapids are being used by one of the company in US. I think this one is on a retail. So they are using rapids to do inventory forecasting when, for example, when the item would be running out, or for example, when they need to purchase, or when they need to get more supplies to the warehouse, or for example, to the shops. They are using rapids to do inventory forecasting, and then they get about 180 times speed up when using rapids with CUDF. And then another example is with streaming media company. So this is, I think, from one of the company that some of you might be watching on for some movies or TV shows. They are using rapids to do a recommendation system. Like for example, what are the movies or what are the TV shows that might be interesting for the customers to watch after you finish a movie, or after you finish TV shows. So they are using rapids to do this. And then another example is within the healthcare industry, where they are using rapids to do epidemic disease predictions. And then in healthcare, still they are one of the company in China. I think they are using rapids to do fraud detection in an insurance company. And then this is from a research lab in the US. They are using rapids to do climate simulations. And then they are using rapids, and then they have about 200 more times speed up when they did these kind of challenges. So basically, there are a lot of things that uh, you can use, that you can apply this rapids technique in basically any challenges that you have in your organizations, or for example in your own industries where you are working on. Because I think nowadays almost every industries, or almost any organizations that you are working on produce data, and then you can do or you can process this kind of data to get some insights, right? So these are actually just some challenges. So yeah, just skip some of these. So at a glance, uh, these are actually just some use cases where the data science problem can be accelerated. Okay, so I just show you some examples where the data science problems can be helped with rapids, like for example, in this consumer internet, or from the healthcare just now, or for finance, in retail, like just now I mentioned about the inventory forecasting or management. In oil and gas, I think there is a lot of interesting topic in almost any industries where rapids can be very useful. Okay, so like for example, just now in telco or automotive. So I'll continue. I think I am a bit short of time, so let me just go uh, quick introductions into software architectures that is offered through Rapids, and then uh, we can see how Rapids are getting more and more developed over the time. We see why that is becoming the reasons into it. Okay. So just now we already mentioned that there are three main libraries in Rapids, which is CUDF, CUML, and CUGraph. So basically, when we are working on these libraries, they are actually using the same data representations, which is Aero, which is coming from Apache Aero. So that's why Rapids can be very powerful because they are actually using the same data representations. So if you think on what is the data frame is actually like a spreadsheet where the data are being represented in a systems. So I think some of you might already know that when you are using GPUs, uh, GPUs are very good when you are working on some sort of data that is represented in 2D or 3D. Like for example, this kind of spreadsheet, I think GPU would really love about data that is represented in this way because of the cores, the CUDA cores just now that I mentioned, that can offer you with a very powerful parallel processing. So I think I'll just skip some of these. So just now when we already mentioned that one of the libraries in Rapids that can help you to do data preparations and data transformation is using CUDF. So basically CUDF can help you to speed up your data loading. Like for example, if you have data that is coming in from a static file, like for example, JSON or CSV. So Rapids can help you to speed up the way you load the data into your system so that data loading can be cut in times. And then other than the CUDF, just now I also mentioned that there is another libraries in Rapids for doing machine learning algorithms, GPU accelerated machine learning algorithm, which is CUML. So some of the algorithms are available in Rapids through CUML, like if you are going to do classifications, regressions, clustering, doing some sort of dimensionality reduction, recommendations. There are a lot of algorithms that you can use in Rapids. So yeah, this one is just now benchmark that is done by NVIDIA earlier, where CUML can cut the times needed to process the data in, I think, more than 110 or more than 120. Like for example, from 2000 seconds to just more than 100 seconds. Okay, so these are actually just some CUML algorithms. So initially, when they first started announcing Rapids, there are actually a very small amount of algorithms available through Rapids. But I think as of the development continue to grow, continue to be developed, I think if you take a look at the latest version of Rapids, there are already a lot more algorithms that you can use as part of Rapids. So that is about CUML. And then the last one is actually the CUGraph, which is another libraries in Rapid that can help you to do some sort of graph analytics, like for example, doing depth first search or breadth first search, like the one that is Google using, which is to do their ranking on their search, which is the PageRank. So these are available as algorithms that you can use through Rapids. Okay, I think I'll just skip some of these. So if you need more information on Rapids, you can visit their website at rapids.ai. This is the only one website where you can see all of the informations related to Rapids, like for example, how you can get started on using Rapids. For example, if you want to try it on your own machine, like for example, if you have a laptop or if you have a computer that you can use with or that you can work with, then you can try to visit this website and see how easy it's actually to set up Rapids on your system. Okay, so setting up Rapids is actually quite straightforward. If you visit their website at rapids.ai, you will be offered by a method of installations that you can go with. For example, if you are already comfortable with working on Python, working on Conda, for example, then you can easily install Rapids via this method. And then another approach is also to set up Rapids using Docker. So basically, it's a containerized or it's a package software offered through Docker. And then we talk about Docker, so basically Rapids is also available through the NVIDIA GPU cloud, which is some sort of repositories or some sort of collection where you can find all of the GPU accelerated frameworks, GPU accelerated software, including those kind of models like pre-trained models or those examples that can get you up to speed on using any GPU accelerated uh, machine learning or AI tools. Okay, so for trying out Rapids on your own, I think the easiest way to try Rapids is to use Google Colab. So I think some of you might already heard about this one. So basically, this is like a free cloud service offered by Google where you can have access into Jupyter Notebook like some sort of instance where you can run uh, Python code or where you can run uh, notebooks on Google instance, on a Google Cloud instance for free. And then the interesting key or the interesting features that is offered through Google Cloud is actually they also offered access to the GPU instance. So when we heard about GPU instance, then you can actually try Rapids on Google Colab also. So for those who are interested on trying Rapids, feel free to access this link that I already offered. So basically, this is a notebook that we already prepared for some cases where we need to introduce Rapids to do some sort of demonstrations to them on how they can start exploring Rapids to see what are the things that is offered by Rapids. So in this notebook, there are some sections that I divided into, like for example, there are some introductions into CUDF, how you deal with the data, how you load the data, how you prepare the data before you can do further analysis or before you can train the data, or for example, if you can apply some algorithms into the data that you have. And then another use cases or another example that I provide through the Google Colab notebook just now is one use cases for predicting patient to be showing in healthcare appointments or not. So basically, this is just to a showcase where Rapids can be very useful in terms of doing predictive model. And then another example is actually to run some machine learning algorithms like another like this clustering with DB-scan algorithms or PCA algorithms. So there is some example that you can try when trying Rapids through the notebook that I already prepared just now using Google Colab. So I think that is all of the slides that I have for today. I'll hand over back to Ragil.
Thank you, Pak Andi Arifin.
Yep.
So I hope you guys, ladies and gentlemen, all enjoyed this amazing presentation. So see how Rapids and the open source ecosystem are advancing data science. So during these sessions, we already explored Rapids, the new open source data science platform from NVIDIA, learned how to get started leveraging these open source libraries, for faster performance and easier development on GPU, saw the latest engineering work and new release features including benchmark, roadmaps, and demos. Finally, we heard the stories on how data scientists across the world are leveraging Sound Rapids in production, how they benefit from early adoption, and how GPU outperforms CPU equivalents. So once again, I hope you all enjoyed this amazing presentation. So now, Mr. M. Andi Arifin will answer some questions that were sent to us during the presentation.
Okay.
So the first question is from Mr. Raffi Aditya Seno Aji from Dia Nuswantoro University Semarang.
Mm-hmm.
Pak Andi, for computer science student, what courses should we focus on to become a data scientist? Am I have to focus to all of the subject, for example, like web programming, computer architecture, software engineering, etc.,
Mm-hmm.
or just related subject for data science?
All right. So, can I answer straight, or you want to?
Yes, please.
Okay. Right. Thank you.
Afterwards, I'll be
So
second.
just now is the question from Universitas Dian Nuswantoro. Is it?
Yes.
Okay. So I think the most important skill set that is needed to in a data science industry, like I mentioned earlier, when we take a look at the research coming in from LinkedIn, uh, they are actually showing some skill set that is needed if you are intending to work on AI or data science industry. Like for example, in order for you to be good at this uh, section is actually, of course, you need to be good at math. You need to be good at your intuition. You need to be very good at your analytics, or the way you think, or the way you uh, address any challenges, like for example how you think out of the box in solving any challenges that is coming in or uh, happening in the industry. And of course, other than that, if I can mention some of the skill set that can be very helpful into this is, of course, you need to be very good at least Python or R. Think that is the top two programming language that is commonly used or mostly used by the data scientists all over the world. So either Python or R, but I think if I should choose between these two, I think Python one is the one that you should go with, because there is a lot of libraries, there is a lot of examples, there is a lot of use cases that you can work with Python, especially there are a lot of libraries all over the internet that you can go with. And then most of the time, if you have any challenges or if you have any difficulties on running something with Python, usually like 95%, 99%, I can guarantee you, there is somebody out there that is already do that for you. You can just use the libraries, the same libraries that you are comfortable with, and then like 95% the problems is solved by just using the libraries, and then that's it. Yeah.
Okay. Hopefully it satisfies your questions, Mr. Raffi. And then the second one, Mr. Andi, it is a question from Pak Bambang Suratno from UII. Mr. Andi, I saw that your company Nova Global has been working with automated workflow and application development. Is it correct if I assume that your company has been working with BPMS, Bizagi, Signavio, etc.? If it's so, how can we relate BPMS with data science then? Thank you.
Okay, thanks. So okay, thank you for the question, Bapak Bambang. So when we mention about an automated workflow or application development that our company is doing for our customer mostly, we are actually providing the customers with a way that can help them to set up some sort of workflow from like a end-to-end solutions where they get the data, where they process the data, so and then up until they can analyze the data and so on. So I think one examples that I can uh, briefly explain on today's session is actually there was a time when we have projects with one of the university in Singapore, I think in about 2 years or I think 1.5 years ago. And then there was a time when we need to set up some sort of data science system in a cloud that was using Microsoft Azure at that time. So we need to help them to provide some sort of workflow for some sort of imaging, satellite imaging, where they need to continuously doing the image gathering. They need to immediately process the data, the image, up until they can provide with some sort of results. Like for example, this kind of systems, they are using it actually to analyze or to do a quick response or to do a quick mitigations into natural disaster. Like for example, if there is a earthquake coming in some region, there is a system that we help them to set up. For example, when there is a earthquake happening, there's usually sensors that is triggered, and then this sensors trigger the workflow, and then the system will automatically capture satellite image around that area, and then they will see the difference before and after the earthquake happens, for example. So uh, when we see the difference between these two, we can see what are the regions that is mostly impacted by the disaster, what are the regions that uh, has been hit by a catastrophic damage, for example. So the search and rescue team, for example, can focus on those areas where they need the most cautions by most of them. So that is actually one example on the automated workflow or application development that we did for our customer. So to be honest, we have not uh, experienced with this kind of BPMS earlier, but if I try to answer an example on how we can do an automated workflow, I think that is one of the good example that we can explain. Yeah. Okay. I think that is my answer, Bapak Ragil.
Okay, thank you,
Yep.
Mr. Andy. I would like to remind once again for the audience, if you would like to ask the question, please use the Q&A button, and also you can raise your hand. I think one more question should be sufficient. But I would like to also announce that all the material and also for the YouTube channel will be shared later, but the material already sent to the audience by using email reminder from the committee. Okay. I believe there is one more question. Is from Mrs. Sri Aulia Ulfa, University of Bengkulu. What about Hadoop, Mr. Andi? For what it uses and why you focus mostly on Rapids?
All right. Okay, so this is actually one of the question that is commonly asked by some of the customers that is working on the data science industry when compared to an existing Hadoop system, Hadoop clusters, for example. How does it compare, and then how the Rapids can be actually a good complementary, a good friends into Hadoop. When we talk about Hadoop, Hadoop is actually how to say, Hadoop is actually most of the Hadoop users are using Hadoop to do in-memory data processing. And then when we talk about Hadoop, uh, they are using system memory to do data processing. Like for example, if you take a look closer into a computer server or computer system, of course, other than processor, you have system memory, the RAM. And then if you take a look on how Hadoop work with the data that you stored in the Hadoop file system, the HDFS, you will see that once the Hadoop, once the files that you have in your Hadoop file systems are being taken for processing into the system memory, and then you can start analyzing the data once you have the data in the system memory. And then when compared to Rapids, Rapids use another layer of representing the data. So instead of storing the data in the system memory in a RAM, they are using GPU. They are using the GPU memory to store the data and then process the data. So when we store the data in a GPU memory, of course, I think it has been common knowledge that I think GPU memory is right now quite limited when compared to a system memory. I think if you take a look at your laptop or for example your computer that you have, I think the most common GPU memory that you have is like either 4 to 8 GB. That is a typical amount of GPU memory that uh, that is available on a common computer system, uh, uh, like maybe in your laptop or in your computer. But if you talk about the RAM, if you talk about the system memory that you have your PC or in your laptop, I think that one can be ranged from 8, 16, or 32, which is usually much more bigger. And then when we talk about how rapids can be uh, more powerful when compared to those traditional processing like Hadoop, is because of the data are being represented in the GPU, and then you can work with the data that you already have in the GPU with the GPU processing power, which is the CUDA. So when we talk about processing the data with CUDA, then we can do much more processing power due to its massive amount of cores, the CUDA cores. So that's why in terms of the performance, Rapids are getting much more powerful when compared to, for example, Hadoop. But we couldn't ignore that Hadoop is a good software, and right now there are still a lot of organizations, there are still a lot of companies that are still using Hadoop, especially for their data storage, data lake especially, and then there are still a lot of organizations that are still uh, using Hadoop to analyze their data. Yeah, I think that is my answer, Bapak Ragil.
Okay, thank you. And one last question is from Mas Farhan from Universitas Islam Indonesia. Is Rapids suitable for beginner in data science, or we have to learn without Rapids first?
Okay, thank you. So, is Rapid suitable for beginner in data scientist? Yes, I should answer that. I think when you start learning Rapids or when you start learning data scientist with Python, for example, I think it is actually is a very close. It can be an apple to apple when you start learning Rapids or if you start learning data science with Python, because when comparing Rapids with those traditional data science tool, like if you take like for example, online courses that is offered through. There's a lot of, I think there is a lot of online website, online courses that you can attend for free. I think they also a lot. They also offers a lot of data science courses. And if you take a look at what are the things that they taught, that they offered through that courses, they of course most of them they offer the courses with Python, and then they also introduce you with uh, the most common some of the most commonly used Python libraries to help you with the data science challenges. Like for example, if you want to, for example, load the data from a CSV file, JSON file into the computer, and then how you can process the data. Like for example, maybe there are a lot of things that you can do before before you're able to train the data. Like for example, maybe cleaning your missing data, or for example, remove some unwanted columns, remove some unwanted data, the outliers, and so on. If they from this kind of courses, uh, the logic is actually the same, because no matter what kind of libraries you are using, the way the way the libraries help you to address that kind of functions of challenges is actually the same. So no matter whether you are using Rapids or you are using other libraries, the algorithms or the logics behind that function is actually the same. And then the most important thing is actually not whether you need to use Rapids or not, but you need to be understanding on how you need to deal with the data that you have. I think that is the most important thing when you are working in a data science, what you need to do with the data, and then what you are trying to get, or what are the things that you want to achieve from the data that you have. Yeah.
Okay, thank you, Mr. Andy. So, thank you again for answering those questions and for the great presentation.
Yep. Thank you.
It was a pleasure to have you with us. So this concludes the webinar session 1. Thank you all of you attending. We hope you learned and enjoyed this presentation. Before we move to the second webinar session, the webinar will be continued with the quiz from the Master of Ceremony. Now we go back to Mbak Safina.
Yes, sir. Thank you very much, Mr. Andi Arifin for the webinar, and also Mr. Ragil for our moderator. So let us have some little ice breaking. So please, Ms. Suchi, please share your screen to have some quizzes. And there are three of the top three of who could fill in the quiz properly and quickly. For the top three, there are some kind of door prizes, and please contact me directly after this quiz is end. Just from this one, you could use any devices such as browser for your PC, laptop, or phone. Joinmyquiz.com, and please enter the join code 818949. And we'll wait for around maybe 70 or 80 participants to join. I think 5 minutes to fill in those informations, it's enough. All right, there are already some of you who already go to the link, and we're waiting for the others. You could, there's some kind of nickname when you're joining. Please use the nickname or name that is related to the email or information that you already put on the registration link. So will be easy for us to recognize if you are on the top three of the quizzes. Okay, let's wait first. And for the top three, the door prize will be e-wallet. it could be provided soon after you guys finish the quiz, and we already have the 3 participants, or the top 3 of those who are already filling the quiz correctly and quickly. Just by chat me privately on this Zoom webinar by giving me some information related to your name and also phone number for us to deliver the money itself. Okay, it's already around 44 participants. Let's wait for around maybe 3 more minutes. Okay. For those who have difficulties in joining this quiz, please let me know. Okay, let's wait for maybe 1 more minute. I think it's already, so Ms. Suchi, could you please start the quiz? Okay, thank you. So let's see who is the top 3 and lucky one who get the e-wallet from the committee. Okay. This quiz is we're having the winner who has answered the questions related to the materials that already delivered by Mr. Andi Arifin about related topic about the big data acceleration, and those who are filling the quiz and answer the questions quickly and correctly are the winners. So make sure that you are listen comprehensively to what our speakers already said, and there consist of 10 questions, and those the red line on my right side, it's about the number of you are wrong answering the quiz, and for the left side is the green one is the number of how many quiz or questions that you answer correctly. And as you guys could see on the screen, there's some kind of competition between each other on that one. And after all of the questions already being answered, we could have the top 3 of that. And we're waiting for all of the participants who are already joined the quiz to finish their quiz set first. On the first one, we have Zach over here, followed by Hafiz, and there's Fika, other one. Okay. And maybe it's a little bit topics that it's really hot and interesting topics to discuss with, because we're living in Industrial Revolution 4.0 when we know that all of the technology, it's more advanced than it used to be, and it's more related to big data, automation, augmented reality, and so on. So it is really interesting topic, and the next one will be delivered by Mr. Ridwan later on after this quiz is done. Okay, who's the winner, I guess? I think it's near to finish because the blank space is shorter right now. Okay. Okay, I think we're kind of have our top 3 who filling the quizzes correct and quick. Okay, congratulations for the first, second, and the third winner. Please, for those who are the winner, let me know your name and phone number so we could giving you the wallet, and please privately comment to myself, to Safina, me, in this Zoom webinar. Okay. Yeah, already a lot of people. Okay. Congratulations for the top 3 who lucky to get the money from us. As I remind you again, please let me know your name and phone number to make us easy to contact you. Okay. The e-wallet will be consist of 100,000 rupiahs, and just give me the for each person 100,000 rupiah for each person, and just contact me in a private chat to make sure that I am knowing your name and your phone number. Okay, so we have 3 over here. There are Amma, Sauki, and Hafiz, right? Please let me know your name and phone number in a private private chat on this Zoom webinar. I think that's all for the quiz and the ice breaking a little bit before we jump into the second topics, and will be delivered by Mr. Ridwan, and please I'll give it hosting again by Mr. Ragil. Please, sir.
Okay, thank you, Mbak Safina. Congratulations to all the 3 winners. Please send your details to the panelists. All panelists is okay for the chat room. Okay, the next, I'm glad to welcome Pak Muhammad Ridwan Andi Purnomo, ST, MSc, PhD, Head of the Department in Industrial Engineering, Faculty of Industrial Technology, Universitas Islam Indonesia, who will present the Studium General Research Opportunities on Big Data Application in Industrial Engineering. The biography of Muhammad Ridwan Andi Purnomo, ST, MSc, PhD is that he was born in Klaten and finished the Bachelor of Industrial Engineering in Industrial Engineering Department in Universitas Islam Indonesia, and also completed both master and doctoral study in National University of Malaysia. The potential research topics on enterprise analysis to increase resilience capability of enterprise will be the topic of his sessions. So without further ado, I would like to call Pak Ridwan to present his case.
Okay, thank you very much for the time. Test, can you hear my voice, Pak Rakil?
Yes, Pak Ridwan.
Okay, let me share my screen. Pak Rakil, can you see
yes,
my slide?
I can see clearly.
Okay. First, good morning, everyone. Now, I try to talk about big data-based resilience for enterprise competitiveness. Previously, we have heard about presentation from Mr. Andi, and we already get a lot of knowledge about the application of big data in industry. So we already have a lot of knowledge about the practical application of big data. Now, I try to highlight the application of big data in industry from academic point of view. First, let me introduce myself. My name is Muhammad Ridwan Andi Purnomo. You can call me Ridwan. I am head of Department of Industrial Engineering, Faculty of Industrial Technology, Universitas Islam Indonesia. Okay, for the introduction, we will discuss about industrial engineering for users because we are in industrial engineering, so we need to limit our discussion on industrial engineering area. And also, I need to explain about the big data at a glance and also the keyword of resilience because we try to get the beneficial of big data to improve the resilience capability as the competitiveness for enterprise. Okay, if we are talking about industrial engineering, actually there are three focuses. The first called as design, the second called as installation, and the third is improvement. And then we also need object to be analyzed, and the object is integrated system. And there are 1, 2, 3, 4, and 4 components to be integrated, which are machines, people, materials, and information. Information is something new, it's new here. So if we try to relate information with data, it will be very strong relation between that. And object for analysis, actually we have two objects for the instant objects. The first called as enterprise and second called as supply chain. But for this occasion, I limit on enterprise only because of the limited time. Okay, now let's continue. For the big data at a glance. Okay, here I can present the data from statista.com. We can see that there are huge data that can be obtained. Okay, and from a lot of sources. For example, from YouTube, in a minute, there are 500 hours of video uploaded by users. Okay, and from the other social media, we can see there are a lot of data. And also from Zoom, now Zoom become very popular software during pandemic time. There are more than 200,000 participants join in 1 minute in Zoom. So we can imagine there are huge data that can be obtained. If we can try to process the data, then we can get beneficial from the data. So actually, if we try to conclude, there are 5 keywords if we are talking about big data, commonly called as 3V plus 2V. The first 3V is volume, variety, and velocity. The size of the volume will be huge, and the variety, because there are a lot of sources that can be the source of the data, and also the speed of the data that flow to us is very high. So, the velocity will be the next keyword. And there are another 2V that can be considered. The first called as value. As engineer, after we get the data, of course, we must be able to process the data, become value, become knowledge. And after that, we can use it to do some decision making. So actually, we can get value from the data. And also the veracity, because the data is original from the user, it means that we can believe the data. If we try to compare with another technique to collect the data, for example, if we do if we spread out questionnaires, for example, then sometimes user cannot fill the questionnaire honestly. But using big data, actually we can get correct data from the user. Okay, now let's talk about the pipeline analysis in big data. Actually, if we are talking about big data, we very close with open source technologies. You can see from this slide. For the data collection, because we are talking about data, so the first step is we need to collect the data. We can use Kafka as the open source, or we can use Amazon. Amazon, we can get the data from Amazon really. And for after that, for the next step, called as data analyzing, we can use Hadoop or Spark and so on. We can see from the slide. And after that, if we want to store the data, then we can use MongoDB, for example, Cassandra, and so on. And at the end, if we want to retrieve the data or if we want to manipulate the data, we can use data querying. For example, we can use Spark SQL or Pipeline DB. So all of the technology here is open source, so we can use it free. So as student or as engineer, actually we can try to start to get benefit from the big data. Okay, after I reviewed more than 50 papers, then I can try to conclude. If we try to relate big data with industrial industrial engineering, I mean, and there are three focuses: design, installation, improvement. So actually, after that, we still need to integrate the big data with data mining. For what? For clustering and for prediction. Why we need to do that? Because we need to predict the condition in the future. After we can predict the condition in the future, then as engineer, we can try to anticipate that condition. So we can prepare our company well because we already predict that will happen in the future. Then we can prepare our company well to face that the condition. Then let's talk about resilience. If we are talking about resilience, actually we can try to short the definition become change and transformation. This is very important now because our condition now is uncertainty. For example, previously we never think about pandemic. Now we are in pandemic time, so resilience now becomes more important. And then there are the two terms that can be used to define resilience. The first is change, and second is transformation. And if we talk about resilience, there are several keywords that we can try to analyze. The first is we can start from here. The deepest one to have. The company must understand about the resources that they have. And after that, the company must have redundancy. What does it mean? It means that the company must be able to copy the resource that they have to do another jobs. And after that, network is very important now. And then the information, again, we are talking about information. And then the experience must be managed well in order to manage the company. In the future, the company can learn from the experience. And then the knowledge and the diversity and also the robustness of the company when facing the noise. There's something happened that never predicted before. And then after that, if we are talking about resilience, it's performed by innovation. So now we know, every company tries to educate the employee become innovative employee, and also creativity, flexibility, collaboration, self-reliance, and also feedbacks. This is very important. After the company prepare everything, don't forget to get feedback because we need to adjust the company step by step based on the real conditions. So feedback now becomes very important. As industrial engineers, we discuss we talk about system thinking. System thinking means that after we design our system, then we need to aware that in the future we need to adjust our system step by step. So here also we need feedbacks. So now feedback become very important. And resilience sustained by self-organization, increasing learning and individual capacity, and also rapid response. That's for resilience keywords. Okay, now let's talk about big data application in enterprise applications. Okay, if we are talking about enterprise, actually we can discuss from at least 6 areas. And the first 3 areas are demand management, product development, and also production planning. We can try to imagine a real company. In a real company, the first step is the company will receive demand from the customer. Of course, after that, the company must collect and also manage the data about the demand. And after that, the company, if the company wants to implement big data, then the company can do analysis, influencing, and also predicting the demand in the future. And after that, besides the demand information, the company will receive information about the situation of the product in the market from the customer. So based on this information, the company can try to develop their products. So there are 3 keywords actually. If the company wants to implement big data, value creation, the company must think about the value to be delivered through the product to the customer. And the second is for the idea generation, how to generate idea to design the products. And the third is the competitiveness in the market. The company must aware with the competition in the market. How the company positioning the products compared to the competitors. And then After that, after the company receive the order from the customer, then after that the company can go to the production shop floor to do production planning. After I review several papers, then I can conclude there are two big issues in the production planning when the company implement big data. The first issue called as maintenance for the machines, and the second called as machine scheduling. Later we discuss about this topic in detail. And then for the second three area that are warehouse management, after the company receive order from the customer, then besides the company can deliver that information to the production shop floor, the company can also deliver the information to the warehouse to check the stock of the products. And then after I review several papers about warehouse management, there are two issues that can be highlighted here. The first called as vendor managed inventory, the second called as vendor selections. And then after that, the company must aware about the human capital management as well. And then when I try to review some papers on that topics, I found there is one issue, important issue about human capital management, which is performance management. And then for finance, this is very, very interesting. When I try to review several papers, I still cannot find. To the best of my knowledge, I still cannot find previous study about the application of big data in finance. But finance is finance department, not finance company. When I try to search over the journal portals about application of big data in finance company, there are a lot of studies for that. For example, how to analyze the customer, how to analyze the credit proposed by the customer. But that's for finance company. For finance department, to the best of my knowledge, I still cannot find a topic about application of big data to that departments. So it's still widely open for us to investigate about the application of big data in finance department. Okay, now let's talk in detail about big data in demand analysis. This is the first area in enterprise analysis in demand management. In the first topic, we talk about demand analysis. When I try to search upon the internet about the previous research on that, there is not much studies on this topic for demand analysis. But there are several studies on that. Usually the objective is to balance the provided facilities with the demand. We can imagine, as company, we need to provide facilities to fulfill the demand. But if we are talking about big data application on this in demand analysis, usually the objective is to balance the provided facilities with the real demand. And then after that, the company can go to this reactive facility management. This is new term, in facility management. Reactive facility management means that when demand pattern is starting to change, then provided facility is need to be adjusted. So after I conduct studies on that, then I can present this diagram to give us clearer upon the concept behind this. Okay, for the demand analysis, then the first thing is about the provided facilities, and after that, because we need to balance between the provided facilities with the demand, then we can try to identify the predetermined variable that influence the demand. And after that, we can try to identify the source of every data here. And sometimes we need big data because some of the data is unstructured. For example, we can try to get the data from social media, from image of the products, from marketplace. So the format of the data is different. That's why the data cannot is not in uniform format. So it's called as unstructured data. That's why we need big data to support our decision making. Still talk about demand analysis. Okay, if we try to incorporate resilience in facility management, then dynamic system could have new variables using big data. So here, this is new thing. If we want to conduct research on this, on demand analysis using big data, actually we can try to widening the scope. because usually the previous researcher just use predetermined variable. But if we try to get feedback from the real system, sometimes we can find new variables that never considered before. So it will be very interesting if we can consider that variable. Yeah, for example, now we have a very good example. If we try to analyze our condition now, we never think about pandemic before. Yeah, suddenly we got pandemic. So if we can use big data, then actually we can try to extract the new variables that influence our company's demand like that. So I propose this is new framework for us. Yeah, we can try to investigate this issue. Okay, now we can try to add the predetermined variable with new variables that can be obtained from the real system. So after we implement demand analysis, we can try to analyze the real system. Then at the end, we can create a system that can be used to obtain the feedback from the real system. And after that, we can try to extract the new variables. And after that, we can incorporate the new variables to our data source. Then we can do this as a loop. And then, so actually, based on this framework, we can try to improve the provided facilities. And then it's called as resilience in facility management. Now, the second issue in demand management is demand influencing. Okay, factors that influencing demand is categorized into two categories. The first called as uncontrollable, the second called as controllable. For the controllable factors, could be said to influencing the demand. Okay, for example, if we are talking about time series, demand forecasting, time series data is uncontrollable. We cannot control it because already happened. Yeah, the demand in the past already happened, so we cannot control it. We just use the data. But besides uncontrollable factor, we still have controllable factors. So we can try to implement big data to get this controllable factors data. And after that, we can do demand analysis to predict the demand in the future. How to do this? Okay, this one. I get from economicsdiscussion.net. There are 6 controllable factors that can be considered. The first called as taste and preference. Okay, and then in here we can see some example. In Yogyakarta, for example, because I'm living in Yogyakarta, there are a lot of coffee shops now in around us. So because there are a lot of coffee shops, the demand of coffee now become increasing. People maybe before this never drink coffee, but because there are a lot of coffee shops around us, then people start to think how to get coffee like that. And then after that, because a lot of coffee shops around us, then the demand of coffee will increase. It means that we can use it. We can get this data. After that, we can try to see. We can try to set the fashion and also advertisement. To influence the opinion of the user to increase the demand. The second called as income of customers. Sometimes as engineer, we need to help our customer. Why? Because when our customer has high income, then our customer can purchase our products more. How to help our customer has high income? Then we can try to develop new distribution channel for our customer to market their products. When they can market their products, then they can get high income. Then they can purchase the products from us more. Like that. And then the third called as change of price of related products. This is about the issue. We can try to set the issue. Change of price of related products. Identify the combined products, analyze the price, and determine the correct price for the observed product. What does it mean? For example, if we try to sell sugar, then we cannot just think how to sell sugar as single products, kind of like that. We can try to think about how if we combine sugar with coffee. So then we can try to analyze the price of coffee, coffee price in the market. if the price of coffee in the market is lower, then of course the demand of coffee will higher. In that situation, then we can sell our products, because people usually purchase coffee and sugar. Our product is sugar. The demand of coffee getting higher because of the price, So in that situation, we can try to sell our product. So the demand of product will be higher, like that. And then the next is advertisement expenditure. Advertisement to show superiority of the products. This is common. If you are talking about advertisement, of course, we can try to promote our product using advertisement, and also we can try to set the trend to set the trend of people using advertisement. Number of customers. Okay, this is very important. Identify new niche market. And sometimes company fails to identify the customer. Okay, or we can try. The company can try to generate new customer from the product bundling effort. The company can try to bundle the product with the other products, and then after the product is bundled, then there will be new potential customer for the products. And then the next is about the future price. When the future price would be higher, some customer will purchase more products for stock. This is also normal, So actually, we can try to get this issue. Then after that, using big data, of course, Then after that, if we can try to identify, if we can try to predict the price of product in the future, and then, now we can try to prepare our production capacity. Because, if the product, the price is higher, then the demand of our product will be higher. Then, at that situation, we need to prepare our capacity, to produce more products. Okay, now for the third issue in demand management is demand prediction. The commonly used method for demand prediction are semi-structured and unstructured data to forecast. Semi-structured and unstructured data to forecast. Of course, if we are talking about semi-structured and unstructured, it comes from big data source. Or the second, we can use structured data plus unstructured data to forecast. Or we can use structured data plus unstructured data to forecast. Okay, we can see from this diagram. From for the unstructured data, we can get from the promotion. As we know, after we conduct promotion, that we know the condition, but sometimes we fail to extract the data from that. That's why now we can start to think about big data techniques to get the data from the promotion effect, and also the pricing, and so on. We can try to identify the other unstructured data here, and after that, from the structured data, we can create causal forecasting and also time series forecasting. We can prepare causal data to do causal forecasting, and also we can prepare time series data to do time series forecasting. And here, we can extract some of the data from the unstructured data using subcombiner in order to identify the cumulative effects, and after that, we still to implement data mining, and from here, we can try to combine all, and in order to identify the cumulative effects, and after that, we can try to combine it with this structured data, and then here we can implement data mining for forecasting, and at the end, we can get accurate forecasting result. Okay. And this is new topic, this is new topic. So we can try to investigate more after this presentation. Now we go to the second area called as product design. Actually there are three keywords in NPD, new product design. The first called as systematic, the second is customer driven, and the third is sales cost oriented. Systematic means that when we design our products, then we need to consider the capability of our company. We cannot just design very futuristic product and after that we cannot produce it. For what? Or after we consider the capability of a company, then we still need to consider the capability of our supplier. Sometimes we need very specific, very particular materials, or sometimes we need very particular technologies. So if we don't have it, then we can ask our supplier to supply. If our supplier doesn't have that capability, so yeah, we will fail in our product design. At content system, we need to consider all of the elements in the product design, to have new successful new product design. The second, because our product will be used by customer, then we need to consider the customer one. Sometimes called as voice of customer. We can try to get the voice customer from a lot of sources. Now we don't need to conduct offline investigation to get voice of customer. We can use social media, for example, to identify the sentiment of the customer to our products, or we can use marketplace to get the review of products. That will be the honest data from the customer. And don't forget, after we design the products, then we need to get profit. So here, we need to consider the third factor in NPD called as sales cost oriented. How to sell the product, how to get the profit. Because we cannot just think how to fulfill what customer want. Cannot be like that. We need to consider upon the profit for our customer, for our company, to make our company survive in the market. Okay. Now, if we try to implement big data, then I can propose this diagram. For the structured data, we still can spread out questionnaire. After we can identify the required data to do product design, then we can try to design the required data. After that, we can try to design the questionnaire. It means that after we get the result from the questionnaire, we already have structured data. The data format is already fit with our requirements. It calls as structured data. Also, we can do brainstorming. In the brainstorming, we can try to drive our respondent to give the data that we want. But from the unstructured data, we can consider social media and also the marketplace. Because the data is still unstructured, then we need to make it more structured. So here we can try to implement machine learning. For example, we can use artificial neural network or artificial neural fuzzy inference system, fuzzy logic, convolutional neural network, and so on. This is the methods in machine learning to make the unstructured data become more structured. And after that, from here, we also have unstructured data from suppliers, because supplier is the entity beyond our company. So we can try to get the data about suppliers using big data. For example, we can try to get data about technology capability of supplier, the reliability of the supplier to supply the material that we require, and also the price. We can also try to predict the reliability of our supplier in the future, based on the demand, based on the review from the other customer, like that. And also we can try to predict the price that will be given by the suppliers to us from the existing condition using big data. And after that, here we can use structured or unstructured data from the internal company. As I explained before, we need to consider our capability when we design products. Then here we can try to develop IoT system. We can try to install several sensors in our machines in order to identify the capability of our machine that we have. And also here we can develop e-business system to manage the collected data from IoT system. And at the end, we can combine all of this data, and after that we can implement these formal methods in product design. For instance, we can implement Kanse engineering, quality function deployment, value engineering, and also trees. This is the new techniques to develop the products called as trees, and so on. We can try to implement other techniques to redesign our products. Okay, here I can propose new thing for to increase the resilience capability. We can consider upon the circular economy, because we have a lot of products now. For example, if we look at our handphone, I think almost all of us have more than one handphone. Yeah. And maybe if we try to analyze our old handphone, maybe we have more than 5 handphones. For example, me, I have more than maybe already 10 handphones. Yeah, start from the first handphone until now. So the question is how to recycle this. I don't want to sell my handphone because of the data inside. But when I don't use it, then this is just trash in my house. So how to recycle it? Now, yeah, in circular economy, then we can try to incorporate some aspect in circular economy, and after that, in our product design, so our product will be more sustained in the future. And also during pandemic period, we can try to extract new parameters, then we can incorporate the parameters to design our products. Now we shift to the next area in production planning. Yeah, the first issue is maintenance. Yeah, start from maintenance optimization, because if you are talking about maintenance, actually, we talk about preventive and also corrective maintenance. Preventive maintenance means that we can propose maintenance system to maintain the system before breakdown. Yeah, the challenge is how to create reason why the machine is still okay, still running well, but we need to do maintenance. Yeah, sometimes our manager will ask us about that. Corrective maintenance means that we need to maintain our machine after breakdown. Sometimes we need longer time because the machine already breakdown, so we need longer time to correct it. Then after that, we can try to combine both maintenance system. Then we can try to implement FMEA, failure mode effect analysis, then to create this one. This is new, predictive maintenance. Based on FMEA, we can try to predict when our machine will break down. If we can try to predict, then we can anticipate. Once before breakdown, then we can do maintenance like that. So now we have new term, predictive maintenance. Then here we can use IoT applications. For example, for real-time monitoring for machining parameters, we can try to install sensor to our machines in order to monitor the machining parameters real time. When the parameter is not in standard, in standard, when we can propose, we can propose maintenance. We can try to monitor the temperature, the humidity, and also the inventory of our spare parts. And also here we can implement machine learning in order to support our predictive maintenance. I also put some note here. Some problems are human resources capability and ability to conduct maintenance. Sometimes it's not. We still have some problem with the human resources. About the capability and also the availability. So here we can try to consider smart society 5.0. This is new thing. So when we are talking about maintenance, then we can try to combine it with Smart Society 5.0. There are 3 areas in Smart Society 5.0. For the parameters, the first called as Smart System and Network. And the second called innovative education, environment and biology, and mass customization. For the second, smart maintenance, this is very related with our issue upon the maintenance. Man-machine collaboration. Using big data, using IoT application, actually, we can increase the man-machine collaboration. Or maybe we can try to use another technology. For example, we can use virtual reality, to train our labor, to train our labor with new technology. So, using that effort, we can increase this one, man-machine collaboration. Man educated by man. Man educated by man. So, but we must think from this one, smart society point of view. So we can think how to educate our employee, of course, using virtual technology, and also machine educated by man. Now using virtual reality, we can try to train our machine. For example, if in our company there are several robotics arm, instead of programming the robotics arm manually, we can try to train our robot using our movement, using our hand movement. Then after that, the system can memorize it, then can generate the programming code to be embedded in our robotics arm. So we can train, yeah. Instead of programming the properties manually, we can train, yeah, using our hands movement. And machine educated by machine. This is very interesting. Yeah, actually we can try to develop technology using IoT to make our machine able to discuss with another machines. Yeah, to discuss with other machines to conduct training. And then automatic predictive innovation, zero failure, and also big data analysis, advanced diagnostic, new intelligent manufacturing system. So actually, we can try to incorporate this aspect in predictive maintenance in order to increase the resilience capability of our maintenance system. Still in production planning, the second issue is in machine scheduling. Yeah, using IoT, yeah, or before that, yeah, in conventional scheduling, we just consider about the production process, upon the processing time, and also the availability of the machine. When we have job and when we have new products, for example, to be produced, then yeah, we can try to distribute this product to our machine by considering the availability of the machine. This is conventional techniques. Yeah, but if you're talking about real condition, actually, yeah, our machine is not available. Sometimes our machine is not available. Sometimes our machine is still doing some jobs, yeah, so we need to have reactive scheduling. And here we can consider the machine failure, yeah, because of course, yeah, as machine we need to do maintenance for our machine. It means that our machine will have some probability to be failure, yeah. So we need to consider this probability. Then, after we have reactive scheduling, then it can be extended by integrating CAPP, computer-aided process planning, with energy consumption consideration. This is new issue in CAPP. Because usually CAPP, computer-aided process planning, it means that after we design new products, after we identify the required components, then we need to identify the required process to create the components. Then we do it using computer. That's why I call it as computer-aided process planning. And this process usually just consider the availability of the machine. But now we can try to incorporate the energy consumptions, because now we have a new issue about sustainability. So yeah, one of the issue in sustainability is about the energy consumption. So we can try to incorporate this factor using big data, using IoT application. And this is the diagram proposed by Ji and Wang in 2017 about reactive scheduling. Yeah, here, okay, and we can start from here. Yeah, we can start from shop floor hardware. Yeah, in shop floor hardware, we can install IoT. We can install several sensors. After that, for analytics, yeah, we can use cloud database. And here, yeah, we have big data analytics, and also we have this one pattern identification. And after that, yeah, for the application, yeah, we can try to incorporate, yeah, with CAPP. First, we can start from order analysis, and then workpiece representation. Yeah, after we break down the products become parts, then yeah, we can do pre-scheduling, and after that, we can consider for prediction based on this data. And after that, we can get integrated scheduling and so on. Now, let's try to discover new thing in production planning. CAPP plus IoT-based scheduling. This is the new thing that we can propose here. Yeah, it equals to sustainable integrated process planning and scheduling. So we can incorporate the new term sustainable. Okay, we start from here. New design products. After that, yeah, we can try to identify the parts and the required parts. Then after that, yeah, using structured database, then we can have 3 process planning. In industrial engineering, there are 3 types of process planning. We can use variant process planning. It means that actually, yeah, we can learn from the experience. Yeah, we already at the past, and we already produced some similar parts, so we can retrieve this database. Yeah, to identify the required process for the new parts. It's called as variant process planning. And generative process planning is totally new. Yeah, we never consider the previous database. So when we require new parts, then we can try to identify the required process using generative process planning, or we can create objects, and after that, we can retrieve the objects to define the required process for our new parts. And then from the unstructured database, we can use IoT-based machine scheduling, to consider about the processing time, upon the machine availability, and also upon the energy consumption. Because using the sensor, we can try to monitor the machining parameter real time. And then, if the parameter is not in standard, then the energy consumption will be higher. So, in this situation, we can try to consider this, in our CAPP. So, at the end, we will have sustainable integrated process planning and scheduling. This is new term for us, so we can try to investigate, on this if we have some preference, on this field.
I'm sorry, Pak Ridwan.
Yeah.
There are 3 more minutes left.
Oh, okay. Yes. Thank you for the reminder. Okay, now we go faster, Big data in supplier selection. This is if we shift to the next area, context warehouse management. This is big data in supplier selection. In big data, there are 3 main issues about velocity, variety, and volume. So we can try to incorporate big data in supplier selection using based on this diagram proposed by Lamba et al. 2019. And then this is for resilience in vendor managed inventory. So we can try to increase resilience capability in vendor managed inventory. And this one using this diagram. This is our vendor. Then we will give authority to our vendor to manage our inventory. Then after that, we can use big data based vendor selection. So from the vendor, we can try to get feedback, using big data. After that, we can incorporate this data, to adjust our vendor selection system. And here also we can use IoT, for our ASRS, automatic storage reservoir system. We can implement IoT, to have smart inventory system, and we can incorporate the previous issue about sustainable process planning and scheduling. Then we can provide executive information firm capacity for our executive, to make business deal with the partner. Okay, for human capital management, we can try to incorporate big data to improve about the capital management. So one of the focus is for performance management. We can start from the firm vision and missions. And from this vision and mission, we can cascading down to be department's goal. And after that, we can cascading down again, become individual targets. And after that, we can use this one. After that, we can install sensor, IoT-based wearable sensor to our employee, to convert, energy consumption to productivity. This is new, if you have preference on this, you can study on this more. How to convert energy consumption to productivity. So we can imagine we can install a sensor to identify the energy consumption of our worker. Then we can convert the productivity, so we can predict the productivity in the future. And besides individual target, we can try to analyze the attitude, from the social media and using data mining. And then this is a new field that we can try to discover for the career management. So we can use big data-based workshop media advisory system for employee. Because we understand our employee has different behavior. When employee work with machine, then it will have a machine surrounding. So because we understand our employee has different condition, then when we want to conduct some workshop, then we need to provide workshop with different media for our employee. How to identify the condition of our employee? We can use big data to identify the condition of our employee. And also, we can try to do this employee rolling based on personality. In conventional system, we just roll. We just try to we just try to repositioning our employee without some consideration. But now using big data, we can try to consider the personality of our employee when we do rolling. And also for retire management, retire management for retired employees, we can use big data, based business development for retired employees. So we can try to educate our retired employee to have business based on big data. Based on big data to identify the potential market, then can be related with the personality of our retired employees. So based on this condition, then we can formulate new business for our retired employees. Big data in finance still widely open. Again, this is for finance department. But if we try to identify the finance department jobs, it can be performance-based salary management. So we can do finance department can do salary management based on the performance. How to identify the performance? We can implement the previous techniques using big data, and also asset value prediction. If you are talking about asset, this is very hard to identify. For example, if we have employee A with some skills, how to digitize this, how to convert this become numeric, so we can identify the value and the asset value. This is very hard. So we can use big data to convert our asset become numerical asset, so we can identify the value. Firm health monitoring system based on liabilities and equity, and also customer credit management and so on. Because as company, sometimes we must allow our customer to pay us by credits. So here we need to have credit management. For example, to define the maximum limit credits for our customer. So in order to set this maximum credit, we can use big data to identify the capability of our customer to pay the credits. This is from the references, just the important references. I think, but actually more than this that I use, and I think that's all for my presentation. I give back the time to Pak Rakil. Thank you.
Okay, thank you very much, Mr. Muhammad Ridwan Andi Purnomo. I hope you all enjoyed this amazing presentation. Guys, during these sessions, we explored potential research topics on enterprise analysis to increase resilience capability of enterprise. So now Mr. Ridwan will answer some questions that were sent to us during the presentation. Is there any question? Okay. This is from Bu Diana. For industrial engineering student, specifically if we interested in conducting the research regarding to this, when is the appropriate time to start exploring topics? What subject should we learn deeper?
Okay, thank you very much for the question. If you're interested in conducting the research regarding to this, when is the appropriate time to start exploring topics? What subjects should we learn deeper? Okay, it depends on our preference. So when I lecture about research methodology, the first thing to identify the research topic is based on our preference. We need to identify our preference. For example, if we prefer to discuss about, let's say, production planning, then please focus on that. Why we need to define based on our preference? Because if we have difficulty, if we have some obstacle, then we can solve it. Because this is our preference, like that. And then, of course, we need to spend our time, to be involved with the topic. How to do that? Of course, we need to read a lot of papers. To be involved with our topic, we need to read a lot of papers, like that. And then, that's the answer, Pak Arkil.
Okay, thank you. And then the next question is from, wait, I will skip the anonymous first. From Bu Nurdiana Azmi. Doctor, I am first year industrial engineering undergraduate student from University Technical Malaysia. My question is, how exposed are the industrial engineering undergraduate students in UII about big data, and how early are the students exposed to it? Starting what year?
Okay, actually start from 2005, if I'm not mistaken. We already formulated that we will focus on IT-based manufacturing. So start from that. We try to have some subject about that. That's why here we have subject about artificial intelligence, intelligence system, like that. And we have database management system and so on, in order to make our student become familiar with the data. because data now become new commodity, yeah, in company, in industry. So we need to be familiar with the data. And then also we provide students with some elective courses like now, yeah, big data. And then I think there are a lot of elective courses in UE, yeah, in our university about this. Yeah, let's say intelligent manufacturing system, and previously we have what we call it, business intelligence, and so on. This of subject that discuss about how to manage the data and how to make decision making based on the data.
Okay, the next one, Pak Ridwan, is from Dewi from Industrial Engineering UII. I want to ask you how to maintain the security of the big data. Because of big data needs high performance hardware, it means industries must have high investment for the IT. Otherwise, industries has to put into cloud. The security of data becomes in danger, how to manage it, and especially for the small business.
Okay. Okay, to answer this, I think I need help from Mr. Andy. So I invite Mr. Andy to help me to answer this. Please, Mr. Andy.
All right. So, yeah, no problem. So, in terms of securing the infrastructure, actually, they securing the big data or data science infrastructures, including the data itself. The first thing that is actually important on securing the data is actually how you can secure the data itself. We have experience in such deployment where the data are actually very sensitive to nature in a way, because there was a time that we are working with a healthcare industry, and then in terms of the healthcare data, patient data is very sensitive. It shouldn't be exposed to an external parties. And the first thing that you can do when we are talking about data sensitivity is actually securing the data itself. There is a lot of algorithms, there is a lot of method to secure the data. For example, to anonymize the data, like for example, you can, of course, when you are working with this kind of data, you can remove any personal informations from the most of the time when you are working with such data, you don't need to have the name of the patient, you don't need to have the phone numbers, you don't need to have an email of the patients. That kind of thing you can do some sort of anonymization process where you remove that kind of personal informations or any information that can lead people into a specific person. So that is one way to secure the data by actually process the data itself so that it looks generic, but it can still be processable with any algorithm that you are working on. And then another layer that you can do is, of course, on the infrastructure layer, where you need to do some sort of access restriction. There is a lot of topics regarding the RBAC, like role-based access control. Like for example, when you are talking about people accessing the infrastructures, there is usually a lot of access level, or there is a lot of how to say, permissions that is granted only to a specific users. So you need to take care on who can access the system. So I think that's why I think our country, like the one that is actually lacking from a government perspective, if I can say, is actually our country, our beloved country, Indonesia, is actually still lacking of some sort of uh, personal data protection act lah. In a way, in Indonesia we can call it like undang-undang perlindungan data pribadi. I think that one is something that is still missing in our country, which is lacking of the government support. And if we take a look at the Europe, they already have the GDPR, like data protection for their people. And then in Singapore, they have PDPA, which is acting about the same. But in our country, they still do not have such thing, because I think if we take back a few months ago, there is an incident that is happening in one of the most popular e-commerce in Indonesia. I think some of you might be aware of that. There is an indications that uh, other people can access something that they shouldn't be, right? So uh, of course, when we are talking about securing an infrastructure, it is important. And of course, when we talk about uh, whether the deployment is on a local premise, like for example in your own local server, or for example whether it's in the cloud, actually securing both things are about the same. First, you need to manage how users can access the system, and then there is a lot of factors that you need to do in order to be able to log into the system. Like for example, I think some of you might already aware that two-factor authentication is already one of the important thing. So in order to log into the system, usually other than typing in, for example, password or PIN, uh, that you also need to provide some sort of alternatives, like for example, entering the OTP or entering the token that is generated only once. Because when we talk about this kind of authentications, two-factor authentications, there is some people said that authentication can be done in several ways. The first is that with the thing that you know, like password, PIN, and so on. And then the thing that you have, for example, using your phone, using your USB drive, using your smartwatch, for example. And then another thing is that with something that you are, like for example, your eye, your fingerprint, so that it's not easy for the other uh, to imitate you or to become you by providing those kind of layers. I think, yeah, yeah, there is a lot of things that you can do to secure the infrastructure, and I don't think uh, uh, I can introduce that in such a short time, because there is a lot of factors to in terms of securing that kind of setup. Yeah, I think, yeah,
Okay,
that's
thank you
my.
very much.
Yep.
Okay, thank you very much, Mr. Andi.
Mm-hmm.
Or I can add another idea, yeah, because if we are talking about authorization, actually we can try to develop our own encryption method, our own encryption algorithm.
Mm-hmm.
So we cannot just use standard encryption algorithm, because now, yeah, we want to put our data in cloud. So yeah, we need to have our own encryption methodology, or we can try to use a different database format, because now database technology is developing. So we can use, yeah, different database format to store our data in cloud. One side, we need the cloud server because we don't want to invest a lot of money. But in another side, we need to consider upon the security of our data. That's all.
Yeah, thank you. I just want to add that something that is intriguing me is that if we go to the shop like supermarket or any other shop, if we use a debit card or credit card, we give the credit card to the employee. But in overseas, I believe that we put our card in ourselves by ourselves in the machine itself. But yeah, I think that's one thing that happened in Indonesia only. Okay, I believe that there is no more question. Thank you again, Pak Ridwan Andi Purnomo, for answering this question, and also Pak Andi, and for the great presentation. It was pleasure to have you both with us. So this is concludes the webinar session 2. Thank you for all of your attendance. The session will be continued with the closing speech from both speakers. Pak M. Andi Arifin, would you please summarize, concluded, or giving closing remarks for today's sessions, especially to the student who will learn data science in the beginning, or share your work experience?
All right. Thank you. So I think for the students, especially when for those who are just beginning, uh, starting to learn about data science, my recommendation is actually uh, uh, do a lot of readings, do a lot of trying, do a lot of experiencing what is available on the market, on the paper, on the publications, on the GitHub. A lot of resources available online that you can try with. Like for example, just now I was mentioning that by using Google Colab, for example, you can actually try a lot of things, not only with the data science, but you can also actually doing a lot of AI, deep learning, machine learning, a lot of things that you can do with these kind of resources. My recommendation actually maybe in a week you can spend like for example 4 to 5 hours just to try out doing some sort of these kind of challenges. Actually, there is a lot of unique things that you can try. Like for example, for myself, from my perspective, usually just for fun only, right? Just for fun only. Usually, if I got any kind of spare time, I usually try out with those kind of unique programs that people write on GitHub, for example. Like for example, some of them they try to create a codes that can replicate your voice. For example, uh, by just recording your voice for just 5 to 10 seconds, we can create a program that can synthesize uh, your voice by, like for example, if you type in some sentences, then it will read the sentences using your own voice. That is one example that I tried a few moments ago, and actually it works great. Another thing that you can try, for example, uh, there is a lot of people already doing it. Like for example, doing uh, currently, I think COVID is one of the important challenges. There is a lot of researches done on that area. Uh, there is a lot of tools. There's a lot of algorithms that is quite interesting to try. Like for example, if you have an image of your organ, for example, there is actually another toolkit that is recently announced by NVIDIA. They call it as a NVIDIA Clara. So just I've been trying out, I think, for the past few months, and it's actually good at doing that kind of medical imaging analysis where you can see or predict whether the some sort of people are towards positive in COVID diagnosis or not. So there is a lot of things that you can try with. Either it is fun or not, my recommendation actually just try and see what the people out there is currently doing. So I think yeah, just try to make yourself fun, and then just try to make yourself aware on what are the things that is going on in the world right now. I think that is my closing statement, Bapak Ragil. Thank you.
Okay, thank you, Pak
Yep.
Andi. And then Pak Ridwan, would you also give a summary of the session also?
Okay, thank you very much for the time. Just short closing statement from me. As engineer, we must be aware with the data. Now data is becoming new commodities in industries, so we need to be aware with that. But data is just data. We must be able to process data, become knowledge, and after that, we must be able to process knowledge, become information and become knowledge. And after that, we can use the knowledge to do decision making. And that's the closing statement from me, Pak Rakil. Thank
Okay,
you.
thank you, Pak Ridwan, and also Pak Andi. Ladies and gentlemen, this is the end of the presentation sessions. To add the graciousness and blessing from Allah Subhanahu wa Ta'ala, please end this session by saying Hamdalah together. Alhamdulillahirabbil alamin. Thank you for all of your presentation. We pray that all the panelists and attendees are always in the good health, safety, and best form. Amin. Me as the moderator send my apology if there are some mistakes. conducted, and hopefully we can all learn together by this session. I will hand back to Mbak Safina for the continued session. Billahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Mr. Ragil, and also for Mr. Andi Arifin and Muhammad Ridwan for amazing presentation and also sharing our knowledge about big data that is, related to Industrial Revolution 4.0. And for the next session, it's about the closing, and I will give you some information regarding to our next Studium General. Let me sharing my screen first. So for more about the international program that is related to this Studium General, we also have the related topics on that. Please kindly follow our Instagram, as you already see in our screen, for the international undergraduate. And please fill in the provide your feedback. This link previously shared via Zoom reminder link on your email. This bit.ly/bigdata UII and to get the e-certificate just for the participants who are already filling the form. And for our next event is about the standard and conformity assessment as an enabler of ICT-based health services. And will be had on 11th November 2020 at 8:30 a.m. to 12 p.m. So it is near to this one. And this is more about the webinar about the standard and conformity assessment as enable of ICT-based health services that Mr. Taufik already delivered when he delivered his opening speech. And you could use the barcode also for the registration link. And for the second Studium General, it's about the machine learning for biological data mining, and it will be had on November 21 on 2020. And the speaker, it's from the Professor Anirban, it's from the India. And the second speaker is Mr. Windanur Cahyo. He is one of the a lecturer in industrial engineering also, and he will be presenting about the social media data mining. So if you are interested in those topics, please kindly fill in the registration link. And that's all from me. If you have questions regarding the international program or anything related to our event, please kindly DM about that, direct message on our Instagram, and please kindly follow and turn on your notifications on our Instagram. So if we have update, you will get notified and you won't miss any update from us. I think that's all from me as your master of ceremony if this event of Studium General. Thank you very much for your attention. Thank you for all of the amazing participants, for all of the guest lecturers. Thank you for all of the speakers. And me, as the master of ceremony in the Studium General, would like to apologize. For all of the participants, you just fill in the feedback form, and maybe in 2 or 3 days, we will inform you later on about the certificate itself. And I will share the link into the chat box. Okay. Just copy the link on your browser, or it is already provided in your link before. So thank you very much for your attention. If there's a mistake, I would like to apologize. It's the name of the committee itself. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Thank you so much, everyone.